Okay, use the discriminant to understand the nature of the quadratic and graph. The equation for the discriminant is equal to b squared minus 4ac. Now, if this is less than 0, it means that it has no roots, so no x-intercepts. If it equals 0, it's only got one root or one x-intercept, which means it's a perfect square. And if it's larger than 0, so positive, it's got 2 roots and 2 x-intercepts. So basically what they'd look like in a graph, that might be for less than 0, where it doesn't cross the x-axis. This one might be right on the x-axis with only 1 point, and this one might cross the x-axis somewhere, giving 2 points like that. Okay, so this is A, this is B, and this is C. So delta equals negative 11 squared. Now, negative squared is always a positive, minus 4 times 10 times negative 6. So straight away, negative times negative is a positive, so we know that this discriminant is positive. This means it could be this shape going through the x-axis, or it could be that shape going through the x-axis. So it's got 2 roots or 2 intercepts. Now if you have a look at the coefficient A, it's a positive, so it's going to be that shape rather than that shape. Now let's find the turning point. The turning point is at x equals negative b on 2a. And that equals 11 on 2 times 10 equals 11 on 20. And the y value of the turning point is y of 11 on 20, which equals 10 times 11 on 20 squared minus 11 times 11 on 20 minus 6. And that equals 10 times 121 on 400 minus 121 on 20 minus 6. So let's get the same denominator, so multiply by 20 top and bottom there, and multiply by 400 on 400. And that equals 1210 minus 2420 minus 2400 on 400 equal negative 3610 on 400. That equals negative 9.025, and the x value in decimal form is 0.55. So the turning point is 0.55, negative 9.025. So let's find the roots. We've got AC equals negative 60 and B is negative 11. Let's try 6 and negative 10. That doesn't work. 5 and negative 12 doesn't work. 4 and negative 15, that works. So we've got 4, negative 15. Now we've got to divide by 10 on both sides. So that's a 2, that's a 5, that's a negative 3, and that's 2. I just factored them down, treating them like fractions. So we've got 5x, that's this value, plus 2, that's this value, and then 2x minus 3, which is this value. And that equals 0, so x equals negative 2 on 5, or x equals 3 on 2. Now the y-intercept is at x equals 0, y equals negative 6. And then finally, because A is a positive, it's going to be this shape rather than this shape. So graphing all those points, we've got, obviously this is not to scale. Our turning point is at 0.55, negative 9.025. And then we've got our 2 x-intercepts and our y-intercept at negative 6. And so the graph looks like so, where the axis of symmetry is through x equals 0.55 through the turning point. Okay, part B, the discriminant is equal to b squared minus 4ac, which equals 12 squared minus 4 times 9 times 4 equals 144 minus 144 equals 0. So what does that mean? That means that it's only got one solution to the root, so one x-intercept. So it's going to lie somewhere like that where the x-intercept is actually 1 point. Okay, let's find the turning point. So that's at x equals negative b on 2a equals negative 12 on 2 times 9 equals negative 12 on 18. They can be factored down. Negative 2 on 3. This is the root to our equation because it lies on the x-axis and it's our turning point. So let's find the y-intercept. So y-intercept is at x equals 0, and from this equation y equals 4. So we've got 0, 4. And then looking at the coefficient, it's a positive, so the shape is going to be that as opposed to that. So the info that we know is the turning point and the root is at negative 2/3, and that's also the axis of symmetry. And it goes through y equals 4. So it looks a bit like that. Obviously not to scale. And this is our axis of symmetry at x equals negative 2/3. Okay, let's move on to part C. So we've got A, B, C. A is 1. The discriminant equals b squared minus 4ac, and that equals 2 squared minus 4 times 7, and that equals a negative. So what does this mean? It means there are no roots, so no x-intercepts, so it could be anywhere hanging in space like that. So there's no point trying to factorise this one. It's not going to have any roots at all. Now let's look at A. A is positive, so therefore it's going to be that shape rather than that shape. We can find the coordinates of the turning point, so let's go x equals negative b on 2a. That is negative 2 on 2 equals negative 1, and y of negative 1 equals negative 1 minus 2 plus 7, which equals 4. So our turning point is negative 1, 4. And we can also find the y-intercept at x equals 0, y is equal to 7. We just look at this, substitute 0 in, and we can see it's 7. So 0, 7 is the y-intercept. So then going ahead and graphing this, we have negative 1, 4 is our turning point. Now we've worked out that it's positive, and 0, 7 is our y-intercept, so it's going to have this sort of shape. And then the axis of symmetry goes through the turning point at x equals negative 1.